Good day to one and all present here. In this video, we will be covering about maths. Maths, boring isn't it? So when it comes to maths, the first thing what comes to in everyone's mind is, where does we apply this? Where does all these come from? I guarantee you children, in the end of this video, we will not only learn the application of mathematics, also we will be learning how did people came to find out all these theorems, laws and so-called etc. stuffs. Okay, before we get into the subject, let me start with the argument. So now look closer. Why is 0 factorial equal to 1? So we all know that people are of two types, right? People who just blindly mug up what other professor says, or who just try to experiment. Have you ever thought why is 0 factorial equal to 1? But don't worry, in this video we will be learning that. I am going to argue why 0 factorial equal to 1. At the same time, we can argue why is a power 0 equal to 1. How is it so? Well, let's simplify stuff to get more deeper knowledge about it. The first thing, what is a power number? What is a power of number? Consider a square. A square is nothing but product of a number a by itself. Similarly, a power 3 goes for the same, a into a. But in this case, then why is a power 0 equal to 1? Well, for that, let's discuss it with an example. Consider this, 2 square. So we know that 2 square is 4, 2 power 1 is 2, and similarly 2 cube is 8, 2 power 4 is 16, 2 power 5 is 32, and so it just goes on. Well, look closely. When the number goes forward, we all see a pattern that is followed. We have no reasons to think that when going backwards, the pattern changes. The same goes here. So when it goes from 32 to 16, it is divided by 2. Similarly, it gets 2 power 4 to 2 power 3, it is divided by 2. From 8 to 4, it is divided by 2. From 4 to 2, it is also divided by 2. So again, if we go backwards, 2 power 1, we get to 2 power 0, which is nothing but 2 divided by 2, which gives 1. The pattern keeps following. Consider 2 power minus 1. It is nothing else than 1 divided by 2, which is 1 by 2. So this is the same pattern we are going to follow here. See now, for example, 1 factorial is equal to 1, 2 factorial gives 2, 3 factorial gives 6, 4 factorial gives 24. Look closely. Here it was simple because we did the same number. What's the pattern here? Now see, if we just divide 24 by 4, we get 6. Similarly, if we divide 6 by 3, we get 2. If we divide 2 by 2, we get 1. And on the whole, if we divide 1 by 1, we get 0 factorial. Gives meaning, doesn't it? Now, this is how people came to understand this. Now, let's see another example. Consider this diagram. Consider this waveform. This waveform is just a random waveform. I just do it myself. Now, a French mathematician called Fourier proved and stated that any random waveform in this manner can be represented as A sin bx. Well, where does he actually apply it? It comes, why did Mr. Fourier found this? So it all comes to our base pocket. So it all comes to our base. Where does Mr. Fourier apply it? It's all comes to our base, our cell phones. We can control anything from here using our cell phones. The phone calls, the sound waves. So what are all waves? We found it regularly. The sound waves, the Wi-Fi signals, be it any random waveform, are represented through this format, such that random applications are there. So that's how Mr. Fourier, when Mr. Fourier actually found it, he doesn't surely know that this was the application, because at this stage there were not even a cell phones or whatever may be of that kind. So now let's see. This is how Mr. Fourier came. On the whole, why did Mr. Fourier discovered A sin x px? He just thought the pattern was interesting. That's how the same thing followed in each and every understanding of maths, be it any concept, be it Pythagoras theorem or whatever theorem for that reason may be. Maths was just simply found because of an interest or curiosity developed by a person. The applications were found to be later on, be it such huge applications or such small ones. So children, learn maths not just with concept problems just plugging up. Find an application so that you can develop more about it. Thank you.